All right, we're on page 12 of the pack. We're doing the penny drop example. So let's get into it. A penny is dropped from the top of a parking garage and strikes the ground in 0.96 seconds. And so it might seem, by just reading that it only gave me one piece of information. Penny dropped, hits the ground in 0.96 seconds. But there's more information in there, and that's where we need to kind of think about our problem types and some of the wording they chose. So my penny is going vertically downward, so I know it's a 1D motion problem. So I'm going to list my variables. Now because it's in the vertical direction instead of x's, I'm going to use y's. Why not y, right? And then it's a free fall problem because as soon as you let go of that penny, the only thing acting on it is gravity. And as soon as you know it's a free fall problem, you know the acceleration is going to be negative 9.8 meters per second squared. What's that negative sign telling you about the acceleration? It's telling you it's down. So up is our positive direction, down is our negative direction. What other information can we pull though? All right, so because it doesn't tell us where it starts or where it ends, we get to choose. Okay, so I'm going to choose the ground as a height of 0. So that means at the end, it's at the ground. Now, we got to be a little careful here because as soon as it hits the ground, is it still in free fall? No, because now the ground is pushing on it. Gravity isn't the only thing. So when I say 0 meters here, I'm talking about the instant. Right before that penny hits the ground, that acceleration is going all the way until right that instant. The instant after it's released to the instant before it hits the ground, okay? All right, so what other information? So, because we gotta narrow it down so there's only 2 unknowns. So there must be one other piece of information. And yeah, it's dropped. So what does that tell me? That tells me the initial velocity is 0 meters per second. Okay, and that was because it was dropped. All right, so that was a key word for us there, especially in the vertical falling type of problems. We'll see that word dropped. All right, part A asks us, from what height was the penny dropped? Okay, so I'm trying to find out what was the initial height it started at. So I don't want to find V final. Pick an equation without V final. Equation number 2 will work for us. So I have x equals, y equals y naught plus v naught t plus 1/2 at squared. Let's cross out anything that's 0. So v naught is 0. Now, one thing we got to be careful of here is if I have 0 times t, what's 0 times t going to give me? 0. So this whole term actually goes away. So I'll see some people just cross out the v naught and leave the t. You got to make sure you get rid of the whole term because 0 times t is 0. And then it ends at a height of 0. Okay, so now I have 0 equals y naught plus 1/2 at squared. And we are solving for y naught. So I'm going to go ahead and I'm subtract this 1/2 at squared all the way over to the other side. And so I get y naught equals negative 1/2 at squared. Plug in my values. So I have negative 1/2 times negative 9.8. We see those negatives canceling out. That's a good sign because we started at a positive height. And the time it took was 0.96 squared. Don't forget that square. That would be a real close answer, but not the correct one. And so we go ahead and we type that into our calculator, and we end up with a height of 4.5 meters. All right, 4.5 meters, about 15 feet. Seems reasonable for a parking garage. Probably only a single-story one, but still reasonable. All right, part B wants to know what is the velocity of the penny when it strikes the ground. Okay, so, all right, let's find the velocity. So I want to find V. Let's assume we didn't find y naught, so pick equation number, looks like number 1 will work nice for us. Equation without position. So I have V equals V naught plus AT, cross that out, and I get a V of negative 9.8 times 0.96. So the velocity comes out to be a negative 9.4 meters per second. What's the negative telling me? Down. Now this is how fast it's going when? The instant before it strikes the ground. Okay, again, when we're doing these free fall problems, when we're saying that acceleration is negative 9.8, we're talking about the instant it's released to the instant before it strikes the ground. Every once in a while I'll get someone to say, well, hit the ground, final velocity 0, Mr. Foster. No, we're talking about the instant before it strikes the ground, okay?